All right, here we are in chapter 8, where we're going to be talking about human population. We did already a little bit, but we're diving deeper into human population. So we'll start off talking about our world right now. Our world currently has 7 billion people in it, and there are some countries that have very, very large populations and population growth problems. China's one of them. The central case is about China's population and their culture around it. But China's not the only country that's dealing with this issue. India has a very large population that's growing rapidly, and they haven't put strict regulations into place like China has. So it will soon become the world's most populous country. So the Earth's current population is over 7.3 billion people, and most of the growth is happening in the poorer nations. And so we're going to talk about that down the road. But this graph shows us that China's population has kind of slowed off right below 1.5 billion, probably around 1.4, and India's is really picking up. So it's expected to pass China, looks like around 2025, and pass 1.5 billion around 2032. So not just in these two countries, but the human population growth is growing rapidly. So currently the rate is 88 million people per year we're growing by. So that means every year there are 88 million more people on the planet than there were the year before. And so that means that there are 2.8 people added every single second, which is a lot. Considering the fact that the human population didn't reach 1 billion until after 1800. So humans were on this planet for several thousand years, not only the 1800 years since Jesus, but for thousands of years before then, and we didn't reach 1 billion until 1800, and now we're at 7.3 billion. So currently, 1 billion people are being added every 12 years. So there's 1 billion more people on this planet than there were 12 years ago. It's crazy. You've been alive. In the time you've been alive, the population has increased by like 1.5 billion. This is an example of exponential growth, which I'm sure you probably could have guessed. So exponential growth, by definition, is when a population is growing by a fixed rate every year. And that sounds like it's not growing much, right? Like the growth rate isn't changing, but as the population grows, the percentage of people stays the same, but that means the amount of people becomes much larger. So a small growth rate can still lead to exponential growth. So for example, we'll see in another slide, the Earth's population growth rate right now is at about 1.2%. 1.2% of 1 billion people is a given amount. 1.2% of 7.3 billion people is a lot more. So as the population grows, even with a constant growth rate, the population is increasing exponentially. So this graph shows us 10,000 years ago, there we were. Then it breaks a little bit to years before present. So this is right around Jesus' time. So we can see we first broke 1 billion in the year 1800, right around then. Since then, look at how much, since then, we've had an insane amount of growth. So we said that the Earth's population growth rate is about 1.2%. But it varies from place to place. So this graph shows us where the population growth rates are different. So the white areas are where growth rates are less than 1%, so they're negative. So the population is actually decreasing in those areas. That's Russia and a lot of Eastern Europe and Northern Europe and a couple other countries in South America, and looks like Cuba. Then there's a lot of countries like China, where now I believe that's what it is, in Greenland and a couple other places where the population growth rate is between 0 and 0.75%, so it's growing, but very, very small. Then all that yellow, so all of North America and a lot of South America and Eastern or Western Asia and Australia and parts of Europe and South Africa, that's right around the average growth rate between 0.75% and 1.5%. Then we start increasing, so we see, and most of this is happening in Africa. We see a lot of growth rates up to the red countries have a growth rate of more than 3%. That's more than double the global average. So we can establish the doubling time of a population by taking the number 70 and dividing it by the annual percentage growth rate. So the global doubling time is 70 divided by 1.2, since 1.2 is the Earth's average growth rate. So that means that every 58 years, the population will double, which is really crazy, because if right now our population's at 7.3%, and if you think about that doubling in 58 years, that's a lot of people. China's doubling time before they instituted their one-child policy, read the central case, was 70 divided by 2.8, which gives us about 25 years. So their population was doubling every 25 years. Okay, so some of the reasons that led to the actually, let's go back. We'll go back real quick. So even though our growth rate has remained steady through this time, the growth rate has been about 1.2, but because the amount of people is increasing, the amount of growth is increasing. So the percentage is staying the same, but we're still gaining more people every single year. So the things that have helped the growth rate increase have been improved sanitation, modern medicine, higher agricultural output, improved technology. All of these things have helped people live longer and have helped decrease the infant mortality rate. So it was very common, probably around 1800 and before then, that babies wouldn't live very long. It was very, very likely that a baby would die, but we've really brought that down. So it's not that humans are reproducing more, it's just that we are now dying less and living a lot longer. So the question then remains, why is population growth a problem? If it's such a good, these all sound like good things. People are living longer and babies aren't dying, but why is it a problem then? And so to answer this question, we want to jump backwards and do a little history. So prior to the Industrial Revolution, population growth rates being up was a good thing because it meant that there were people were living long enough to be able to support their parents. So if their babies weren't dying, then parents would have children to support them. And there was a large pool of laborers to work in factories. So it seemed like a good thing, and the population is doing well. But this guy, Thomas Malthus, was a British economist, and he realized that we were eventually going to, if we kept increasing we were eventually going to reach a problem. And he suggested that eventually people would bring the death rates back because there would be war and starvation and disease if the human race kept increasing the way that it was. And then, so he was around in the late 1700s. And then we also have these current day people, Paul Ehrlich and his wife Anne, who have made similar warnings about the population growth rate. Ehrlich suggested that so he wrote his book in 1968, so 50 years ago, but he suggested that by the turn of the century, or by the end of the 20th century, so now 18 years ago, that population growth rate would unleash famine and conflict that would consume civilization. So that didn't happen, but it's still important to talk about the warnings and the looking ahead to what could happen. So again, despite the fact that the population has quadrupled, these predictions have not happened. That's because we have increased food production, so there is enough food for the people on the planet. That doesn't mean that everyone is getting enough food, but there is enough food. And enhanced prosperity, education, and increasing gender equity have helped slow birth rates. So we're not reproducing as much as we were maybe back in the 60s when he wrote that book. So in spite of these improvements, population growth we're still depleting resources. We're still stressing the social system, so the government's gonna have to control these people, and we're breaking down the natural environment. Okay, so there are several factors that affect the environment, and we have this equation that will help us with it. So it's called the IPAT model because those are the variables that are in it, and it represents how our total impact on the environment is a product of the population, the affluence, and the technology. So increased population means that more individuals take up space, use resources, and generate waste. So that means that we're having a bigger impact. Affluence leads to greater per capita resource consumption. So if you have more money, you have more access to resources. And technology can increase our impact by enhancing our ability to exploit resources or decrease impact by improving efficiency. So we can also talk about this thing called a sensitivity factor, which denotes how vulnerable a given environment is to human pressures. So the example that it gives is that the arid lands of West China are more sensitive to human disturbance due to the slow growth rate of plants there. So if we keep over-harvesting there in an area where the sensitivity factor would be high, we're likely to have a bigger impact. Modern day China has many examples of how IPAT elements can create environmental impact. So intensive agriculture in this Western China has caused erosion similar to the Dust Bowl. So quick history lesson. In the 30s, in the Dust Bowl, which is in central US, I believe, we overfarmed and then we couldn't grow anything and it turned to a big dust bowl and no one had any food. That's what they're referring to. Aquifers and rivers are heavily withdrawn, which means the water table has lowered and there's not enough water available. And air quality is so low in Beijing that breathing it for a day is similar to smoking 40 cigarettes. So the IPAT elements there have really created an environmental impact.